Good morning, students. Good morning to all of you. Today we are going to discuss a questions related to the topic magnetic field lines. Okay, let us see here what the question asking. This question asking about why two magnetic field lines cannot cross each other. Okay, why two magnetic field lines cannot cross each other? Suppose first of all we have to discuss the magnetic field lines. What is magnetic field lines? Then we will give the answer of these questions. Okay, let us see here. Suppose this one a bar magnet, and we know that around the bar magnet there is a field that is called magnetic field, and that magnetic field will be indicated by the magnetic field lines. Okay, the magnetic field lines is a hypothetical or an imaginary lines given by Michael Faraday, which is originate from the north pole of the magnet and terminate into the south pole of magnet. Okay, this one, the rule that the magnetic field lines from in outside the magnet, it originate from the north pole of magnet and terminate into the south pole of magnet. Okay, but in inside of the magnetic field lines is from south to north and it is parallel, so it is uniform magnetic field. There is a uniform magnetic field intensity inside of the magnet, but around the magnet or outside of the magnetic field intensity will be not uniform. Where there is a denser in magnetic field lines, there will be the intensity of the magnetic field will be the larger. Okay, the magnetic field lines gives the direction of magnetic field. Okay, the magnetic field lines will only gives the direction of magnetic field. If you want to find the direction of magnetic field at that point, suppose this one the point P, and you want to find the direction of magnetic field here, then what will you do? You have to draw a tangent on that point. Okay, you have to draw a tangent on that point, or we have to put a compass needle. Okay, we have to put a compass needle here. Then the compass needle, the north pole of the compass needle will indicate the direction of magnetic field. And we have to know here that there is only one direction at one point of around the bar magnet. Means there is only one direction at one point on the magnetic field lines. So we can write here that at one point there is only one direction. At one point there is only one direction, and that direction will be indicated by we put a compass needle, or we have to draw a tangent here. The tangent will give the direction of magnetic field lines, or the compass needle, the north pole of the compass needle will indicate the direction of magnetic field, or the tangent will indicate the direction of magnetic field. On the basis of this theory, we have to answer this question. Suppose this one bar magnet, and we know that the outside the bar magnet there is a field lines, that is magnetic field lines, and the magnetic field lines originate from the north pole of the magnet and terminate into the south pole of magnet. Suppose here two magnetic field lines cross each other. Okay, suppose here at a point P, two magnetic field lines cross each other. Then what will you do? We find the direction of magnetic field at a point P. Then we have to draw a tangent here. For this curve, there is a tangent in that direction, but for this curve, there is a tangent on that direction. What will you do? We see there two tangent you can draw for two curves, but if you put a compass needle here, then what will you see? The compass needle will indicate in only one direction. The compass needle will indicate there is only one direction. Then which one valid? The direction of compass needle or the direction of tangent? We validate the direction of compass needle, because this one the imaginary lines, but the direction of compass needle is not imaginary, because the compass needle will give the direction of magnetic field. Okay, so we valid here the direction of compass needle only. So our contradiction, that we assume that the point where you want to find the direction of magnetic field, you draw their tangent, and we can draw here two tangent which contradicts the fact that there is only one direction at one point. Okay, so we can say that the magnetic field lines cannot cross each other. If they will cross, then you can draw the two tangent, which is possible. You can draw the two tangent for two curves which is possible, but we find only one direction on that point. So we consider only the direction of compass needed, which is fact. So we can say that this is not possible that two curve lines or the two magnetic field lines cross each other in the outside of the magnet. Okay, I think you are able to follow me. Thank you very much.